Okay. Make sure your calculator is set to degrees, so there should be a D, a DEG, or that's about it. If you see R or rad or grad, I know you all want to graduate, but you don't want that for trigonometry, all right? So the safest, okay, I'm going to say this, make sure you listen. Out of all the units, this is the unit where having a good calculator is going to pay off big time. Okay? By that I mean having a two-line calculator. So where you have, like for example, if you go sine of 23 times 5, right? To have both what you've entered and what you're supposed to get. It's going to be very, very important. Okay? So if you want to spend 15 bucks, and if you want to spend them well, spend it on a good calculator. All right, let's review here. Make sure you follow along. At first it's a lot of blah, 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 right? Me just making sure you understand the terms. Isosceles triangle. What do we know about an isosceles triangle? Anybody? It's a triangle where, follow along now guys, two sides are the same, so we use markings or we use numbers. And what do we know about the angles across from them? They're also going to be the same. Which means that third one is not going to be the same. So we kind of use this. Okay. So two angles that are the same and two sides that are the same. Equilateral. I hope you know that one. All three sides measure the same, and all the angles measure the same as well. There's a property about the side length. There's a relationship between the side length and the angles, okay guys? What do each angle measure? 180, if you split that, do we remember that all angles add up to 180 inside a triangle? If you split that equally into 3, that's a 60-degree angle measure. So for an equilateral triangle, you actually immediately know what the angles measure inside as well. So that's kind of cool. A right triangle. We know that it's a right triangle if there is a right angle. Okay. As soon as you have a right angle, we know it's a right triangle. So just a little review there. Do you remember your Pythagorean theorem? What's this side called? No, the name for it. Hypotenuse. Yes. I don't like to use ABC because it could be different. So I don't want to stick with that. I want to know that this is hypotenuse, is across the 90, and therefore this is a leg and this is another leg. Think of it that way. So Pythagorean theorem, if you ever want to know the hypotenuse, you would go square root of leg squared plus leg squared. That is the easiest way to remember. So what are you doing with the legs? You're adding them, right? Adding the squares of the legs. What if you want to know one of the legs? It would be hypotenuse minus leg squared. So this is just an aside. We're not going to use it a whole lot, to be honest. But if it does, it might come in handy at times. It's just a review. Sum of interior angles is always 180. How's that helpful? Well, if you know 2, you actually know all 3. Okay, if you know 2, you know all 3. So A plus B plus C is always going to be 180. Doesn't matter what it looks like. Oops. Oh well, it's okay. If this is 30 and this is 50, what's that one going to be? Let's call that angle A. 100, right? We're going to go 180 minus 30 minus 50. So angle A is 100. So let's see. I can see the province testing you on this in the following way. Let's say you have a triangle like this. And they ask you, what's wrong with this triangle? Why is this not possible? It's greater than 180, right? Can't be. You cannot have 110 plus 50 plus 30 is 190. Can't be. You can actually say triangle does not exist. So that's the first thing I would check. If they ever do what's wrong with this triangle, if I have the information, I would check right away, do they add up to 180? If they do, good. Move on to the next thing that could be wrong. Okay. So this is just an aside. Supplementary angles. What are they? Two, write this down, or more angles whose sum is 180 degrees. So the 180 seems to be a bit of a theme in trigonometry or in geometry in general. So what I want you to know is, if you can see a straight line like this, and you pick a point, any point on that line, and you were to cut it, you now have two angles that together add up to 180, right? Because we all know, or at least you should know, that from this end to the other end is 180. Right? So if I tell you that this is 30, you should immediately know that this angle right here would be 180 minus 30. That's 150. And you might think this is pretty straightforward. Did you get that? Pretty straightforward. This is gonna come up a lot. The province draws on this a lot. So you please don't miss it. That's what I'm trying to say. Like, don't miss this. This is gold. So for example, if they give you a triangle like this, they did one once where they gave students this angle here. So if this had been 120, let's say, it's outside the triangle. It doesn't help you for the triangle itself at the moment, but you should notice, oh, there's a straight line right there. So if that means that from end to end it's 120, so this would be 60, right? So that's how it's powerful, a powerful property. Let's do one more here. I need to squeeze this in. I forgot to add it to my notes here. Complementary. Angles whose sum is, any brave volunteer? What do complementary angles add up to? Not 180, that's already taken. 90. Yeah. Think of it this way. A cheesy way to remember, it is right to complement someone. It is right, that's a right angle, to complement someone. I don't know. That's just me. So how would that be if you ever are told that there's a 90, right? You're told there's a 90 and someone draws another angle in there and tells you that this is 40. you're like, oh, well, at the corner, there's a 90 here. That means if this is 40, this will be the complement to it, which will be 50, right? Because 50 and 40 add up to 90. And 3-letter notation for angles. Yeah, you're going to love this one. Not. But it is necessary, okay? So let's just review this. Angle, so watch this. It doesn't say triangle ABC, right? It says angle ABC. It's an angle. Let's go find it. Just read it the way it's stated. From A to B to C, right? So it's between these two sides here that you've created. So it's actually calling for this angle right here. So let's put a little number 1 there. So we're going to say ABC, that angle right there is number 1. Okay. And I'm going to do one more and then I'm going to ask you to find it. Angle CBD. CBD. Right? So it's you're making them right here. Which two sides are you constantly traveling across? These two, right? So it's that angle formed between these two sides that we're talking about. So put a little number 2 there. Find me the other ones. And for this side, we're going to go letters. Lowercase a, lowercase b, lowercase c. What are these ones referring to, folks? Are these angles? No. It's talking, where's stretch BC? Where would that be? From B to C, it's right here. It's talking about that stretch. So letter A would go right there. So let's go and do 1, 2, 3, 4 like this. Find me these, like on it, you just have to find 3 and 4. And then also put the letters B and C to the side lengths that it belongs to. Try it, try it. Worst case scenario, you get it wrong. Just make sure you have an eraser ready to go. Yeah. I hope this doesn't, from time to time they do 3-letter notation. It doesn't happen very often, but the one time it did, a lot of students got it wrong because they didn't know how to find it, right? So I don't want you to be in that scenario, so I will throw it at you. Got it? C, D, E. C to D to E. So keep driving those stretches, and it's like, oh, it must be, right? This one here, this is 3. BDC, BDC, you're traveling here the whole time. So it's that angle right there, that is 4. I'll AC you on this from time to time to make sure you don't forget. D to B is this stretch right here, so we're going to call that B. D to C is from here to here, that gets the letter C. So we've done, these are segments or side lengths. And these are all angles. Make sure when you review, you know, you remember that there are 3-letter notation for angles. And I think you would all agree, if I said angle D, if I just use it, look at where my pencil is. If I told you find angle D, is that specific enough? There are 2, right? So that's why sometimes we have to use 3-letter notation to be specific. Got it? Let's keep going. We in general use capital letters for angles and lowercase for the sides across the angle. I'm going to say in general, but sometimes I change it up. So for example, if you have let's make a nice triangle like this. And if you refer to this as x, y, z, then technically this triangle would actually be called triangle x, y, z. And so I would expect you to put these letters there. The beauty is it doesn't matter if you go clockwise or counterclockwise. It doesn't, as long as you're consistent. Where is side x? Side x is going to be across angle x. So this angle is across x here. Y, right? Angle y will have side y across from it. And angle z will have side z across from it. That's how it goes. Angles of elevation and depression, do you remember those? What's the key to finding them is you need to have a horizontal. It's always with respect to a horizontal. And I'll try to use my artistic skills and giftings, right, to help you understand. So here we go. 3 hairs like that. There you go. Bad hair day. I just need you to have a horizontal line. I'm going to try using a ruler here. So there's always a horizontal, right? And if you were to look up from that horizontal, if you look up, and let's say there's a bird flying here, okay? You look up to the bird. That is angle of elevation. It's going to be a number, but you need to know where the number goes. It's going to be right there between the horizontal and the line of sight going up. That is the important. It's always with respect to the horizontal. And let's say you see something crawling on the ground. Ladybug or something. Okay. Obviously, from the horizontal, you're going to point down, right? You're going to tilt down towards it, and that's the angle of depression. Maybe I will, one more time, just emphasize, you're going from the horizontal going this way, or from the horizontal going that way. So it's always with respect to the horizontal. And I'll AC you on that, so pay attention. I'll give you a quick example here. Angle of elevation to top of tree is 47 degrees. If I just gave you that sentence and I asked you, give me a little sketch. First of all, angle of elevation, you're going from a horizontal up, right? So a quick diagram would just be, here's my tree. This is where you're going from. So that's 47 right there. Another example, a pilot sees runway. Can you read that? Too small or what? Pilot sees runway at angle of depression of 35 degrees. How would you sketch that? I should have picked something like a bird sees something. Now I have to sketch an airplane. Anyways. So the pilot is up here, sees the runway right here. So I think a lot of you would agree that this is what we're talking about, like the line of sight. Where would you put that angle? There's no horizontal, Mr. Dirksen. Imagine one. Up here where the pilot is, there is a horizontal. So the 35 would go right there. This is your H, right? The horizontal earlier was the ground. That's your H. So let me grab a color that sticks out. I'm just going to say It all has to do with the horizontal, the horizontal, the horizontal. Putting the 35 here is all too common. Students would draw vertical, and they're like, it's right here. That's wrong. It is here. Okay, it's with respect to the horizontal. If you remember that, you're in business. You're never going to get this wrong. Some keywords. I'll just give you already hints for what's, if it shows up later, you're not going to. If it says a tree is due east of you, do you remember your compass rose? I think north-south, nobody mixes that up. But this one, where's east, where's west? You want it to say we when you read it from left to right, not you. Right? I know you did the never eat soggy wieners or whatever works for you. You use that. But make sure you don't get this wrong. So if a tree is due east of you, this is you, and the tree is right here. Because we know that east is to the right, so there it is. Another thing you need to remember, let's squeeze that in here. The distance traveled is speed times the time. Before you get all worried about like this is going into physics, okay? Don't be too alarmed. If you travel 100 kilometers per hour for 2 hours, you traveled 200 kilometers, right? That's all I'm saying there. If you travel an hour and a half, then you would just multiply your speed by an hour and a half, so it doesn't change anything. But this comes in every once in a while. Last but not least, this one burned. I thought I had mentioned it, but it burned a lot of students. Okay, they forgot about this one. Largest angle. What happened there? Largest angle is going to be across the longest side. So therefore what? Smallest angle is going to be across shortest side. Do I need to put the middleist angle? That's not even a term. That's Mr. Isfeld. He told me about that one. I had a pretty good gig. The middleist angle is across the middleist side. I hope I don't need to tell you that one. Because if you know these two, then the only one remaining is going to be across the other side. Okay. So example, how did they get burned? How did students get burned? What they did is this. They went 3, 5, 7. And then they went 70, 80, what is that already? That's 150 already, right? And 30. They're like, what's wrong with this triangle? And a lot of students added up the angles, and they're like, there's nothing wrong. You know what the question says? Explain why this cannot be. It wasn't even like saying like it could be wrong or it could be right. It's like, explain why this is wrong. And everybody was like, there's nothing wrong because it adds up to 180. And what you should check is which one is the largest or the longest side, right? Longest side. But this one is not the largest angle. You see it? The 80 should have been there. So therefore, not a triangle. You can actually say that. You should have the 80 there. And where should the 70 have been? You should have the 30 which is the smallest angle across the shortest side, right? The 30 should have been here, and the 70 here, and so forth, and the 80 should have been there, so it should have just been shuffled. If I just mixed you up pretty good, don't worry about it. We'll do more of that. I just thought I'd throw it in here. And now we get to the meat and potatoes of today's, or whatever your meat and potatoes equivalent would be. Maybe for you it's asparagus. That's fine. Sine law. Okay, this is new, so it's kind of exciting because if you forgot SOHCAHTOA, I want you to keep forgetting it. Like, don't remember it anymore. If you remember it very well, forget about it. I don't want you to use SOHCAHTOA anymore because 99% of the time it's not going to work. Toss it out the window, like, right? So here it is. We use only two laws, something called sine law and cosine law, which is going to happen later this week. We're going to start with sine law. Okay, so how is this new? Previously, you only learned how to deal with right angle triangles. But if it's a non-right angle triangle, which is what we call oblique, it's a fancy term for anything that isn't a right angle triangle, we need new tools. The first new tool is the sine law. Okay. The sine law is a proportion that compares the ratio of each side to the included angle. I will not talk about this right now. I'll probably do it later when we get closer to it. But this is what the sine law says. If you have three colors, maybe use them at this point. It's saying that this angle right here, there's a relationship between that angle and this side. Got it? And there's a relationship between this angle. If you have three different colors, it'd be awesome. This angle right here, and which side? This side, the one that's opposite to it. And there's one more. Is this angle right here across from this side right here. They all kind of look the same, right? Sorry. But I'm going to connect them. I'm going to say there's a connection here. There is a connection between this angle and that side. And there's a connection between this angle and that side. Do you notice that angle F has side F across from it, right? Angle D, which is right here, has side D. Angle E has side E. So I'm going to use the same colors that I used for D. I'm just going to show you one more time how they're paired up. They're paired up. E is paired up. If you don't have colors, just say, hey, look how they're paired up here. And F is paired up. This is what sine law says. Any triangle, if you were to take sine of the angle and divide it by the side across from it, that'll be exactly the same as sine of E divided by E. It'll be exactly the same as sine of F divided by F. That's pretty cool. Okay? And it works with the following scenarios. Should I give you the scenarios? I think I'm going to skip this for now because I think right now this will confuse you more. But this is what sine law comes down to. This is what sine law comes down to. Highlight that bottom part there. This one here. I would have under sine law, I would have this. Remember, if you have a side angle pair, then use sine law. Okay? That's what this is going to come down to. So let's put it to action. And I'll talk about this. I'll fill this in later, okay? I promise. For now, just follow me here. This is actually fun if you know what you're supposed to do. You ready? We're going to start off with just solving for sides, then we're going to solve for angles. But the start is exactly the same for sine law. Okay? Look at this triangle, and what do you notice? And I want you to find the pair that is known. You see it? This angle right here has this side across from it that is known. Okay? So that's my known pair. I have a known pair. Guess what I'm going to use? Sine law. Okay? The province often just gives you a mark for identifying the law you're supposed to use. It's either sine law or cosine law. Those are the only two options. So this is how you start. Look up here. Knowing that this is true, I'm going to use that reasoning to help me out here. Watch this. Sine of B over side B is going to be equal to, what do I have? What else do I have available to me in this triangle? You see how you have that angle right there? That's going to allow you to solve for this side right here. So I'm going to use that as my other pair, even though one of them is unknown, right? The side is unknown, so I'm going to go like this. Sine of A over side A. And you don't need to do this every time. I'm just doing this for your notes right now. Sine of 52 degrees over 16.8 centimeters. Then I'm going to go sine of 72 over A. And I want to stop here and just tell you, this is solvable because all you're missing is 1, right? If you do this and you have 2 unknowns, you're stuck. You can't do it. You got to go back and find something else. A, how do you do this again? You go to the variable, you cross multiply, and you divide. You thought you'd never hear this again, right? Well, you're wrong. So we go like this. 16.8 times sine of 72. I multiply those two. I multiply these two. Then I divide by, in this case, I have to divide by sine of 52 degrees. And here's where I want you to grab your calculator and actually type this in to make sure you get what I'm getting. 16.8 times sine of 72. I hit equals at that point. Then I go divided by sine of 52. All of these are numbers, folks. Sine of 72 is a number. Sine of 52 is a very small number. They're all numbers. And this is what I get. 28, right? And we are in centimeters, right? We're trying to solve for a side length. Boom, you got it. All right. What else can we solve for? Side C? But do we have this angle? No? But we can find it, right? How many angles do we have? 2. We can easily find the third one. That's what I mean. If you have 2 angles, you can find the third one. So let's solve side C. Need angle C, which is 180. Can you see that? There. 180 minus 52 degrees minus 72 degrees. So I subtract these 2 angles from 180 to give me that one. And you get 56 degrees. Very important. Watch how I'm going to solve this. I'm going to continue using the pair that I knew from the very beginning. I kind of tend to do that. Even though you now have a new pair here, I'm going to stick with this one. So I go sine of 52 degrees over 16.8 centimeters. And on the other side, I have sine of 56 degrees. It's going to solve for the side that's across this one, which is side C. So here we go. Cross multiply and divide. See? If you type that in right, you get 17.67. Note, we solved the triangle. I don't know if you remember what that means, solving the triangle. We know all sides and we know all angles. Okay, so this is considered a solved triangle. And the beauty of this is as well is that sine law also works on right triangles. This one right here I would like you to highlight right here. These little bubbles are worth reading. Okay, sine law works with right triangles as well, so it solves everything. Okay. Okay, I'm going to ask you to try that on page 6. Try what we've learned on page 6. Let me just tell you what I'm asking you to do here. Listen carefully before you start, Julian, before you start. I want you to solve for side Z, but also I want you to basically solve the triangle. Okay, so I know this one has M, this one doesn't have a label. I also want you to find that one. So you're basically solving the triangle every time. So solve for one on the left, and then solve for the other side on the right. Okay, so just show me your work, and then move on, and I'll post the key in a bit. All right? Focus on the pair that is given, that is known, and then solve for the other one accordingly. Okay? Have a good one. I'll come and see how you're doing in a bit.